All right, you're a master of JVM threads. Let's practice some more with some small but really powerful exercises in this video. 1. Can you think of an example where notify all is different or acts in a different way than notify? I'm asking because in this case with multi-producers and multi-consumers, I can easily change notify for notify all and the behavior would not change. The reason why that would not change is that at every iteration inside either the producer or the consumer, they're all synchronizing on buffer. So even if I have a number of producers and consumers that are sleeping on buffer and this guy notifies them all, then at the next iteration, all the threads are awake and they will all synchronize on the buffer. So they will all block on the buffer, but one. So only one thread will be allowed to pass through. So notify and notify all are not really doing different things in this scenario. So as you see, the program runs just as fine with notify and notify all. Now I want you to think of a case where notify all acts in an actual different way than notify. All right. Next, I want you to create a deadlock. You probably know what a deadlock is. A deadlock is a situation when one thread or multiple threads block each other and they cannot continue. And 3, I want you to create a live lock. Now, a live lock is also a situation where threads cannot continue, but as opposed to a deadlock, a live lock implies that threads yield execution to each other in such a way that nobody can continue. So the threads are active, they're not blocked, but they cannot continue. So pause the video now and think of some examples, and I'll come back with some in just a few seconds. All right, so first exercise, notify all. Let's create a little method called, let's call this test notify all. All right. And I'm going to create a little synchronization object, and I'm going to name this suggestively a bell for ringing a bell. And this can be anything at all. I'm just going to create a simple string or an object. All right, a plain Java object. Now, I will create 10 threads. So 1 to 10 for each. I'm creating a new thread, and then I'm going to start that, and inside I'm going to say bell synchronized, and I'm just going to wait for the bell to ring. So I'm just going to say bell.wait, but not until I've printed something to the console so that I see that my threads are waiting. So I'm just going to say an s-interpolated string and thread $i waiting. All right, and after the bell has rung or somebody has woken me up, I'm just going to say s, and I'm putting in the same thread identifier, thread I, and I'm just going to say hooray because I've woken up. All right, so I have 10 threads that synchronized on the bell. They're going to print waiting, and then they're going to wait for somebody to wake them up. And I'm going to start an announcer thread. So a new thread with some code. And I'm going to start that. And inside, I'm going to wait for like a second or something. So sleep for 1 second or 2 seconds. Okay. And then under a synchronized expression on bell, I'm just going to say, let's print this out. Announcer, rock and roll. All right. And then I'm going to say bell.notify all. Okay. So this will signal all the threads that they may continue. So let's run this method. So test notify all, but of course I want to comment out the multi-prod cons because these things will run forever and they will obscure our little printing here. All right, so let's go ahead and run this and let's see what happens. All right, so our threads are waiting for 2 seconds until the announcer says rock and roll, and all the threads have awoken and they say hooray. Now, by contrast, if I said instead of notify all just notify, and I ran this, now all the threads are waiting, and then the announcer says rock and roll, but just one thread wakes up, as opposed to all of them. Now, as you see, this program is still running. That means the other 9 threads are still blocked and waiting for some other thread to notify, but sadly, nobody's going to wake them up. So I'm just going to kill the app. So this is a small example where notify all and notify act in a different way. All right. Now, for a deadlock example. So this was exercise number 2, deadlock. Cool. Now for the deadlock case, let's imagine a small imaginary society where people salute by bowing. And when someone bows to you, you bow to them. And you only rise when the other person has started rising. Now, this of course makes no sense because if the other person follows the same rules, then if both of you are bowing to each other, then nobody would ever rise because you are waiting for them to rise first and they are waiting for you to rise first. So people will just stay bowed for the rest of their lives. But that's exactly the point. This is a deadlock. So let's implement a small case class. Let's call this friend with a name. And let's have a method called bow to another friend. All right, so this is a synchronized method. So we are just saying this dot synchronized. We're acting in a multi-threaded environment, of course, and we are just going to print a small s-interpolated string saying this. I am bowing to my friend other. All right. And then I'm going to ask for other to rise to me. And then print line again. This, my friend other has risen. All right. And for the method rise to another friend, this will look like this. Again, this is a synchronized method, so this synchronized. I'm just going to print line this colon, which means that this object is saying, I am rising to my friend other. Okay, and now I'm just going to create 2 friends. Let's call this let's call these friends Sam and Pierre, just for some French variety. So Sam is friend Sam, and Pierre is friend Pierre. All right, and then I'm going to start 2 threads. New thread with Sam bow to Pierre. Then I'm going to start that. And another thread, not thread communication, but thread, in which Pierre bows to Sam because they're friends. All right, and let's see what happens if I run this. So right click and run. The other thing with notify all is running. So let's comment that out so that it doesn't pollute our little console. So now we have this little output where we are saying, Sam, I am bowing to my friend Pierre, and Pierre is saying, I'm bowing to my friend Sam. But both of them are calling the other person's rise method, which calls their synchronized expression, and both of them are waiting to print line this little statement here. What happens here is that this thread blocks Sam's lock first because Sam bows to Pierre, so it calls a synchronized block on Sam. So Sam's lock, then Pierre's lock, and vice versa. The second thread says Pierre is bowing to Sam, so this will lock Pierre's lock, then Sam's lock. But when these two threads act at the same time, they block these two locks, and then they attempt to block each other's locks. So at this point, Sam's lock is taken, and it attempts to lock Pierre's lock, and the other thread has already locked Pierre's monitor, and then it attempts to write Sam's lock, but they're both locked by the other thread. So this guy right over here is a classical deadlock because no thread can progress because both of them have locked each other out. Now this is a classical example of a deadlock where two threads lock two objects in reverse order. All right. Now let's run the third exercise with a live lock as well. And in this scenario, we are going to consider an extremely polite society. Now, in this case, if, for example, you and your friend meet from different directions on the same road and are about to bump into each other, then you must be so polite that you will give way to your friend to cross. All right. But of course, if your friend is also very polite, then he will switch sides and make way for you to cross, and you will make way for him to cross, and so on and so forth, and nobody would end up where they want to go. Now, let's assume in this simplified scenario that there are just two sides of the road. There's the left side, and then there's the right side of the road. So a friend would start with the side of the road on, let's say, on the right. All right. And this, let's say we have a small switch side method, which returns unit, which says if side is equal to right in between strings, of course, then side equals left, else side equals right. All right, so this just moves from left to right and vice versa. All right, and let's create a small pass method, which makes me so polite that I'm passing my way to another friend. This returns unit and says the following. As long as this side is equal to the other friend's side of the road, then I'm going to print line an S-interpolated string saying this colon, so this is saying, oh, but please, other friend, feel free to pass. All right, and then I'm going to switch the side and make way for my other friend to pass, and then I'm going to sleep. So thread sleep for, let's say, a second to allow some time to for my friend to pass. All right, and I'm going to create two threads here. Of course, I'm going to comment these guys out because they're blocked, and also my program is blocked. So I'm going to create a new thread where Sam passes the way to Pierre. Start. And I'm also going to create a thread with Pierre passing the way to Sam. And let's see what happens if I run this. So right-click Run. And look at our little friends giving way to each other. So Pierre says, "Oh, but please, Sam, feel free to pass." And Sam says, "Oh, but please, Pierre, feel free to pass." And then again, Sam says, "Oh, but please, Pierre, feel free to pass," and so on and so forth. And nobody ends up getting where they want to go. This is called a live lock in the sense that no threads are actually blocked because, as you see, nowhere in this code do we have synchronization blocks. But no threads are free to actually continue running because they are yielding execution to each other. All right, we've learned a lot and we practiced a lot. You should now be comfortable with JVM thread synchronization and thread communication primitives wait, notify, and notify all. I'm Daniel and I'm waiting for you in the next lesson where we talk about how Scala specifically handles multi-threading in a truly functional way.